Okay, so there's been a huge new AI release that is making some serious waves. And I'm not talking about some small incremental update here. We are talking about a model from a team with limited computing resources that is fundamentally challenging how we think about building powerful AI. It's proving that a clever strategy can be just as powerful, if not more so, than just raw processing power.
So DeepSeek just dropped not one, but two new models. And these aren't just state-of-the-art for open-weight models. They are going right after the closed-source giants like GPT-4 and Gemini Pro. And really, the big question isn't just what they did, it's how in the world a team with way fewer resources managed to pull this off.
And look, the headlines are just wild. I mean, we're not just talking about good scores here. We're talking about blowing past giants like GPT-4 and Gemini Pro on key benchmarks, winning multiple gold medals in brutally tough coding and math competitions. And, get this, the first ever open model victory at the International Math Olympiad, all while being incredibly efficient.
Now, you could just say, okay, they're just chasing benchmarks like everybody else. But honestly, those scores, as impressive as they are, they're not the real story here. The real innovation, the thing that makes this a potential game changer, is what's happening under the hood.
See, DeepSeek's success isn't about having the deepest pockets. It's built on his really clever three-pillar strategy of technical innovations. These are the software optimizations that allowed them to squeeze every last drop of performance out of their hardware and punch way above their weight class. All right, so let's dive into pillar number one. This is all about finding a smarter, way more efficient way for the AI to handle information, and it's the absolute key to how they're able to do so much with less. So at the very core of any of these modern AIs is this thing called attention. It's basically how the model decides which words in a long piece of text are the most important. But the standard way of doing this, what people call vanilla attention, it's got this huge bottleneck. The more text you give it, the cost to run it just explodes. It gets super expensive, super fast. So here's their brilliant solution. It's called DeepSeek Sparse Attention. Think of it like this. Instead of trying to listen to every single conversation in a crowded, noisy room, their model uses this little neural network, they call it an indexer, to predict which few conversations are the most important. Then it just focuses all its attention on that small, crucial group. This cuts down computation like crazy without really losing any quality.
Okay, so they made the model way more efficient, but how did they make it smarter? Well, that brings us to pillar number two, and this involved a pretty radical shift in how they train their models. It was a huge bet on a different way of teaching an AI how to actually think.
This is where things get really interesting, because it shows the massive gamble they took. Most models, right? They spend almost all their compute time on pre-training, just reading the entire internet. DeepSeek did something different. They decided to pour over 10% of their entire compute budget into the post-training phase, specifically using reinforcement learning to teach the model how to reason.
And to pull this off, you can't just go download some data set off the internet. Nope. They had to build their own, custom-made virtual gym for this AI. I mean, just try to picture this. They threw more than 85,000 super complex problems at it across 1,800 different virtual environments. It was all designed to do one thing, force the model to learn how to reason its way to an answer over and over and over again.
All right, so they figured out how to teach the AI to reason, but how do you teach it what to reason about? So well, that takes us to pillar number three, which is this really clever divide and conquer approach for building one powerful, well-rounded model.
And the thinking behind this is actually pretty simple, but it's also kind of genius. Their whole idea is, look, instead of trying to make one model a jack of all trades from the start, which is incredibly hard, it's way easier to first create a master of just one specific skill.
So here's the recipe they came up with. First, step one, they train these separate teacher models. They turn each one into a world-class expert at just one thing, like math or coding. Then, step two, they have these experts just crank out tons of perfect, high-quality examples of their reasoning. And finally, step three, they take all that amazing data and they distill all that specialized knowledge into one single, super capable general model. It's just so smart. So, how did they pull all three of these pillars together to create that beast of a model, the one that's winning all the competitions? Well, that's where the Speciale version comes in. This is where they took their entire strategy and just pushed it to the absolute limit.
Okay, so for this Spatiale model, they didn't just bet on reinforcement learning, they went all in. They doubled down hard. As you can see, they dedicated over 20% of their total compute, that is a huge chunk, just to this reasoning-focused phase of training. This was a massive, all-in move on reasoning.
And for this super elite model, they added a few extra ingredients to the mix. First, the focus was razor sharp, just math, code, and logic, nothing else. Second, even before the hard training began, they fed it all this curated chain of thought data to basically teach it how to think methodically. And finally, they just hammered it with this aggressive optimization, forcing it to try a problem over 64 times, learning how to self-correct again and again and again.
So, the big question, did all that work? Well, the results kind of speak for themselves. This insane focus led to 3 gold medals in some of the toughest coding and math competitions on the planet, including that historic first for an open model at the International Math Olympiad.
And according to the team at DeepSeek, this is the first time an open-weight model has actually reached the same level of reasoning in math and code as the big dogs like GPT-4. That's a huge deal.
But, and this is important, the team is super honest about the trade-offs they made. Because they bet the farm on reasoning, its general knowledge of the world, the stuff that comes from pre-training, it's a little behind. It also sometimes needs a few more tokens to get to a high-quality answer. And for really complex, multi-step tasks, it's still not quite on the level of the top closed-source models.
So when you step back and look at the whole picture, what does a release like this really mean for the future of AI, for the whole competition between open and closed models?
Well, for one, it's a massive proof point. It proves that you don't necessarily need the most computing power to win, that smart strategy and killer software can let smaller teams go toe-to-toe with the giants, and sometimes even win. Innovation can still be brute force. And that, right there, leaves us with a really fascinating question to chew on. If a smarter strategy can pull this off with limited resources today, what happens when these brilliant open-source methods get their hands on massive-scale compute tomorrow? The game is definitely changing.